Hello, my name is Jade Bridges and I'm the Global Technical Support Manager for Electrolube. I'll be taking you through the thermal management presentation, looking at a variety of different technologies and discussing some examples of where they are used. So firstly, just to have a quick recap on why thermal management is important. Obviously, when circuit boards are in operation, individual components can emit heat. This heat can also build up in discrete locations of the electrical units. With devices getting smaller and smaller, the space on printed circuit boards is limited and higher temperatures are being reached. If you don't maintain an optimum temperature, this does lead to inconsistencies, which in turn reduces the working life and also increases the failure rate of components and devices. Overall, by not managing your thermal behaviour, you will increase the cost. That could be in relation to efficiency of the device or through brand reputation, lack of reliability of the product. I'm sure many of you will have seen metal devices that are known as heat sinks that are attached to circuit board components in order to dissipate the heat. They're designed so that the fins give the maximum surface area to dissipate the heat away. However, where the heatsink connects to the component, you do not have full contact. This is due to very minor surface imperfections. And within these surface imperfections, you will introduce air at the interface, and air is a very poor conductor of heat. As a result, if you put a thermal interface material between them, something that is thermally conductive, like a grease or phase change material, for example, that eliminates all of the air from the interface and replaces it with something that is thermally conductive, that transfers the heat. This maximises heat dissipation and ensures that you're running at the lowest possible temperature for that device. This technology is increasing in all areas of the industry, but it's particularly important for automotive applications, for example, and anywhere where the technology is safety critical or needs to work first time without any failures at all. So as a result, the thermal management sector is one of the largest growing in electrochemical sales at the moment. For your information, there's the equation for thermal conductivity. It's defined as the ability of a material to transmit heat. So when we're looking at our thermally conductive materials, we're measuring the conductivity of the bulk material. So it's not how it is expressed when it's in use. Usually you're talking about thermal resistance and making that as low as possible when you're in your actual application. The thermal conductivity of material is not always constant either. There are some factors that can affect it, such as density, moisture and temperature. However, more crucially, not all thermal conductivity measurements are the same. So when you're looking for a thermally conductive product, you'll be having a look at the thermal conductivity values on the datasheets. However, these may have been measured using different test methods. Unless you have all of your materials tested using the same method, and preferably on the same piece of equipment, you can't be sure that those values are comparable. The reason for this is that each method has a slightly different way of measuring it. It may or may not take into effect any resistance that's at the contact surface between the plate that's measuring the temperature change and the material itself. Because of this, we do advise to exercise some caution when comparing thermal conductivity values on datasheets. They're there as a guideline. You can request for materials to be tested using the same equipment, or you could use them just as a starting point to give you an idea of what level of thermal conductivity you may need, and then go further with testing on your actual unit. To listen to the full version of this webinar, visit the Electrolube website or stay tuned for the next episode.